Hello everyone, welcome back to my channel. It's me Abhay. So today we are going to the second part of kinematics, which is equations of motion. So without any further ado, let us get into this video. So what and all are we going to deal in this video? Let us go through it very quickly. So first, I'll give the general instructions like how I will be taking you through this video. Next, we'll be dealing with the three equations of motion. Okay, which is very important. Okay, how will we go about in this video? Let us see. So first, we will discuss what is the equation. Next, we will be deriving that equation in two methods. One is in graphical method and another is through calculus. This graphical method is very important for board's purpose, for board exam purpose. Okay, now, okay, what is the first equation of motion? Let us see. The first equation of motion is V is equal to U plus A T. So what are the terminologies which are involved? Let us see. V is nothing but final velocity. U is nothing but initial velocity. A is nothing but acceleration. And T is nothing but time taken. Okay. So let me quickly explain what is final and initial velocity. Assume you have a car. Okay. Now assume at time t is equal to 0. Car is moving with a speed. Car is moving with a speed of 5 meter per second. Okay. So what is the initial velocity? Initial velocity is nothing but 5 meter per second. So initial velocity is nothing but assume at some time you have started taking the reading. Okay. So at that time when you have started taking the reading, what is the velocity of the object? So that is initial velocity. Now after some time you have stopped taking the reading. Okay, so assume after 10 seconds you have stopped taking the reading. Okay, what is the velocity of this car? Okay, assume it is 10 meter per second. So final velocity is 10 meter per second. Okay, so what is time taken? T is nothing but what time you have started taking the reading at t is equal to 0. Okay, what time you have stopped taking the reading? T is equal to 10. So 10. So what is total time taken? 10 minus 0, which is 10 seconds. Okay, so this is t, and acceleration is what you can calculate using this equation. Clear? Done. So acceleration here you'll get it in terms of meter per second square. Okay, so generally in questions you will get the units of velocity as meter per second and for acceleration as meter per second square. Okay, but it can be anything. For initial velocity can be given in terms of kilometer per hour. It can be even in terms of meter per hour. Okay, it can be anything, but generally in questions which will be dealing, it will be in the unit meter per second about initial velocity, and acceleration will be meter per second square. Is this clear? Okay, so let us derive the first equation of motion using graph. Now here you have the graph. So in deriving all the three equations of motion, we will be using velocity time graph. Okay, so velocity we will be taking in the unit meter per second, and time we will be taking unit as second. Okay, so this is standard. So velocity will be in the unit meter per second and time will be taking in the unit seconds. Okay, so at time t is equal to 0, okay, car has some velocity. So what is this? This is nothing but u. So this is nothing but u. After some time the person has stopped taking the readings. Correct? After some time the person has stopped taking the readings. At what time? At time t is equal to t. So the at some time t is equal to t second, the person has stopped taking the reading. So this is nothing but t. Okay. So what is the reading? This is what nothing but this gives final velocity. Correct? Is this right? Tell me. At time t is equal to t seconds, the person has stopped taking the reading. So, what is the car has some velocity at that time. So that is what final velocity, right? I told you. So now tell me one thing. What does the slope of velocity time graph give? Slope of velocity time graph. What does that give? What does that give? It gives acceleration. Remember how v by t. This is slope. So v by t is nothing but what? Acceleration. Correct. So slope of velocity time graph gives you acceleration. Correct. Now carefully listen. Now what I will do is I will make a small triangle over here. This is nothing but A. This is B. This is C. And assume this is some angle theta. Okay, clear? Okay. Now, so what is tan theta? Tan theta is nothing but AB upon BC. What is tan theta? Tan theta is nothing but slope. Slope of what? Slope of velocity time graph. Okay, is this clear? Tell me. So, what is AB? This length. AB is nothing but this length. This is nothing but V minus U. And BC is nothing but T. This is T time. So, AB is nothing but V minus U. BC is nothing but T. What is slope of velocity time graph represent? Here I have written acceleration. So, V minus U is equal to A into T cross multiply. So V is equal to U plus A T. So this is nothing but the first equation of motion. Clear? Now we will be deriving the first equation of motion using calculus method. So we will be deriving the first equation of motion using calculus method. So how do we do? Okay, listen to me very carefully. You know, dv by dt is nothing but acceleration. Yeah, so this I discussed in the previous video of basics I was discussing. So there I have given this formula. Now what I will do is I will separate. So dv is nothing but a dt. Correct? What is v? V is velocity, t is time, a is acceleration. Now what I will do? I will integrate both sides. I will integrate both sides. Now very important is limits. Okay. Now assume you have a car. Okay. Now this is at what time t is equal to 0. Till time t is equal to, let us say, some time t. Now at time t is equal to 0, car will have some velocity which is u. Okay, and at some time t is equal to t, the car will have some velocity v. So what are the limits of velocity? It is nothing but final one is v. So this is v and initially u. Okay, and time from t is equal to 0 till time t is equal to t. So times limits will be 0 to 3. Okay, is this clear? Next, so integral dv v from u to v. Acceleration is independent of time over here. Now since acceleration is independent of time, we can take acceleration outside and integrate dt. Okay, so remember all the equations of motion which we are deriving is only for objects having constant acceleration. Okay, if acceleration is not constant, then you have to go by this derivation using calculus. Okay, so that is why this derivation using calculus is very very important. Now, integral dt. So since acceleration is constant over here, you can take acceleration outside. Now, from where 0 to t. Now, this I will write it as, keep it as v. I'll put the limits later. Now, this is here, and integral dt t. If you don't know integration formulas, I have made a separate video for integration. Okay, go check that video out. Now, this is from 0 to t. The limits I have discussed over here. Top. Now put the limits. What is it? Upper limit minus lower limit. So upper limit is v, lower limit is u, is equal to a into t minus, what is this? V minus u is equal to a into t. V is equal to u plus a. So this gives us the first equation of motion. Okay, so this gives us the first equation of motion, and we have derived this using calculus method. Is this clear? So next, first equation of motion we have discussed, and both the equation and the derivation. Derivation we have done in two ways, which is calculus and graph method. So now let us move on to the second equation of motion. So what is the second equation of motion? Here we have, which is S is equal to ut plus half at square. So what are the terms? S is nothing but displacement, u is nothing but initial velocity, a is nothing but acceleration, and t is nothing but time taken. Okay, don't get confused. T square is not time taken, t is time taken. Remember, t is time taken. Okay, yeah. Okay, so now let us derive the second equation of motion using graphical method. Okay, so let us start. Now, again we have a velocity time graph. Now, a very important thing which you should know before doing this derivation is area under velocity time graph is gives us displacement. Okay, what is S? S is nothing but displacement of that object. So this is very very important. So now, so let us find out the area under this graph. So to find out the area under this graph, let us draw some dotted lines. So let us find the area under this graph. So how do we? Let us do this first. Here I will draw a perpendicular like this. What do we have over here? Here we have a trapezium. So we have a trapezium. So directly we can find out the area using the formula half into base into sum of two parallel sides. This is the formula for area of a trapezium. Okay, but since some of you don't know this formula, we will do it from basics. Okay, let us assume you don't know this formula and let us do it using that method. Okay, so how do we do it? First, we will construct a triangle. How do we do it? We will construct a triangle, right angle triangle, right? This is a right angle triangle. So this is also perpendicular. Clear? Now, let us label the parts. This is origin O, this is A, this is B, this is C, this is D. Okay, so this is this thing. Now, let us start with the derivation. So, let us go with the general terms. OA is nothing but what? Initial velocity. Why? Car at the time t is equal to 0. car has some velocity, that is initial velocity. At time t is equal to t, car has some velocity, that is final velocity. And OD is nothing but time taken. Okay, so let us start the derivation. So area. So what is the total area? Total area is nothing but what? Area of triangle ACB plus area of rectangle. This is rectangle. What? AODC. Correct? Area of this triangle plus area of this rectangle gives us the total area under this velocity time graph. Correct? Now, what is area of triangle ACB? Half into base. What is base? AC into height. What is height? BC plus area of rectangle. What is area of rectangle? Length into breadth. What is the length? It is nothing but OD. And what is the breadth? Breadth is nothing but OA. Okay, so now what is it? Now it's simple. Yeah, nothing but what? Half into AC. AC is what? AC. AC time taken. AC is what? Time taken. AC is nothing but equal to OD. OD is equal to time taken. So AC is T. What is BC? BC. V minus U plus OD. OD is what? T. T into OA. OA is nothing but U. Correct? So this is nothing but what? Half into VT plus half UT plus UT. So this is minus. Yeah. So which is nothing but what? Half VT. So half UT minus half UT is plus UT plus half UT. Okay. Correct. Now I will erase this part. So this is nothing but what? Area. So this area is nothing but S. So what I can do is S is equal to half. I can take out common. T I can take it out common. V plus U. Okay, correct. I'll erase this also. Clear? Okay. So what was the second equation of motion? S is equal to ut plus half at square. Now, do you see any final velocity in that equation? Do you see v in that equation? No. So here, but here, what do we have? We have final velocity. We have to get rid of final velocity. How? Remember the first equation of motion. V is equal to u plus a t. So what you have to do? Here you have v. So instead of v, put u plus a t. So this is from first equation of motion. From first equation of motion, v is equal to u plus at. I will take it as, I'll mark this as equation number 1. I'll mark this as equation number 2. So I will write put 2 in 1. So by putting 2 in 1, what do you get? So you get S is equal to T by 2 into B is nothing but U plus A T plus U. S is equal to T by 2 into 2U plus A. Multiply these things now. So S is equal to half into T into 2U plus half into T into 80. So 2 cancels. S is equal to nothing but UT plus half A T. So this is nothing but our second equation of motion. So we have derived it. We have derived the second equation of motion using graphical method. Yes, this clear. So let us derive the second equation of motion using calculus method now. Okay, so let us derive the second equation of motion using calculus method. Okay, so how do we start? What do you know? You know the x by dx by dt gives us velocity. Okay, now the important question over here is, this is velocity. Okay, is this initial velocity or is this final velocity? How do you know this, if this is initial velocity or is this final velocity? Okay, so let us understand that first. Okay, assume you have a car which is moving at time t is equal to 0. Car will have some velocity u, that is initial velocity, and at time t is equal to t, car will have some velocity v. Now what is dx by dt? Okay, let us understand. When a car is traveling some path, okay, it will have different velocity at different time intervals. But whatever path, assume you consider this path, you consider this path, you consider this path, any path which you consider, initial velocity will be same, but displacement will be changing. See, this path is smaller, this path is larger, this path is larger, like that. So the displacement is changing. Okay, but initial velocity is always same. This is not zero, this is same. Okay, initial velocity is same. Okay, if this v was initial velocity, if this v was initial velocity, then irrespective of path taken, irrespective of whether you take this here, final velocity would have been same. But is the final velocity same always? Need not be. Okay, need not be. So here you can have assume here it is 5 meter per second, here it can be 7 meter per second, here it can be 10 meter per second. So it is changing. So this should be final velocity. Okay. Now let us actually go through the derivation using calculus method. Now it is quite easy after this point. So using first equation of motion, using first equation of motion, what do you know? You know v is equal to u plus a. So v, I will write it as u plus at. Clear? Any doubt? Now I will multiply t that side, dt that side. Take t that side. So dx upon dx is equal to u plus at dt. So what I'll do, I will integrate both sides. I will integrate both sides. Now, deciding the limits. I have traveled some path. Initially, it was 0. Displacement at time t is equal to 0 was 0. And at some distance s, at some time t is equal to t, car has traveled a displacement s. So, x starts from 0 till s. X is from 0 till s. And time is nothing but from t is equal to 0 till time t is equal to t. Now just integrate both sides. Integrating both sides, this is nothing but x from 0 to s, which is nothing but integral u dt plus integral a t dt. So this I will put it over here. This is nothing but s minus 0, which is this is s minus 0. Integral dt is nothing, u is constant with respect to time, initial velocity is same. So integral dt, I'll do one more step, plus a into integral t dt. So this is nothing but s is equal to integral dt is nothing but t. So time is 0 to t, 0 to t. So u 0 to t, integral dt t from where 0 to t plus a. Okay, now important formula. What is the formula of integral t to the power n dn dt? Sorry, integral t to the power n dt is nothing but what? T to the power n plus 1 divided by n plus 1. Here n is nothing but what? N is 1. Now put that over here. T to the power 1 plus 1 by 1 plus 1. So s is equal to, this is u 0 to t plus a into t square by 2 from 0 to t. What I will get? What I will get? S is equal to ut plus half a t. So what did I get? S is equal to ut plus half a. And what is this? This is nothing but second equation of motion. This is nothing but our second equation of motion. Is this clear? Tell me. So we have derived the second equation of motion using calculus method also. So now let us go to the next, which is third equation of motion. So what is a third equation of motion? Let us see. So third equation of motion is v square minus u square is equal to 2as. What are the terminologies? V is nothing but final velocity, u is nothing but initial velocity, a is nothing but acceleration, and s is nothing but displacement. Clear? So nothing new terminology which I have to explain. All of this I have explained, all the terminologies have been explained in first and second equation of motion. So let us quickly go into the derivation. So first we will go to derivation using graphical method. Okay. So let us derive this using graphical method. Now first I will draw trapezium. So first let us quickly draw one trapezium. Yeah. So this time I will directly be using the formula for area of a trapezium. So here what you have? I have a trapezium. So what concept are we going to be using? Area under velocity time graph. Area is nothing but displacement. Clear? Okay. So let us label this, which is origin O. This is A. This is B, and this is C. Okay. So now quickly tell me what is OA? OA is nothing but initial velocity. BC is nothing but final velocity. OC is nothing but time taken. So again, all of this, y is OA initial velocity, BC final velocity, and OC time taken. I have explained it in first and second derivation of first and second equation of motion using graph. So yeah, so that's why I'm keeping that again, keeping that explanation again. Okay, so is this clear? Okay, so what is uh, area of trapezium? Area of trapezium is nothing but half into base into sum two parallel sides. Okay, so all of you know this thing. If you don't know this thing, you can go using the method which I used for area of a trapezium. Oh, sorry, which is like split this graph into a triangle and a rectangle, then find the area. Okay, which will get the same thing. So now, important thing over here is what is base and what are the two parallel sides. Half. Mean, what is base? This is base. So base is nothing but OC. And you can see that these two are nothing but parallel sides. See, there are uh, four sides of a trapezium, correct? No, these two are not parallel. You can see AB and OC are not parallel. So OA and BC are what? Parallel. So these are two parallel sides. So which is nothing but AO plus BC. Area after under trapezium is nothing but what? Area under velocity time graph. Area under velocity time graph gives us displacement. OC is time. AO plus BC is nothing but AO is nothing but U, BC is nothing but V. And don't you think this is what we got in the first part of the derivation of second equation of motion? So this we have got it directly. Okay. Now what we are going to do is little different over here. Okay. Now what is the third equation of motion? V square minus U square equals 2AS. Now, anywhere do you see the dependence of time? No. So, what are we going to do? Yes, we are going to extract time from first equation of motion. How? From first equation of motion. V is equal to U plus A T. V minus U is equal to A T. V minus U by A is nothing but T. So T is V minus U by A. V minus U by A. So what I'll do, I will put T as V minus U by A over here. Okay. So substituting that S V minus U by A into V plus U. Now, do you notice something? v minus u into v plus u. It is in the form of a plus b into a minus b, which is what? A square minus b square, which is v square minus u square by a. So cross multiply. So 2as is v square minus u square. Okay. Now what I will do is, or simply I can write it as v square minus u square is 2as. Is this crystal clear? So we have derived the third equation of motion using graphical method. Is this clear? Let us derive the third equation of motion using calculus. Now, before I go with the derivation of third equation of motion using calculus, there is one important result, okay, which I want to discuss, which I think I have not discussed in the previous video. Now, let us go into maths for some time. There is one important formula. Assume you have two functions A and a function B. Assume you have two functions A and B. Assume I differentiate a function with respect to time, dA by dt. I differentiated B with respect to time. What do I get? dB by dt. Okay. Now, when I divide dA by dt, dB by dt. Okay. You can write it as dA by dP. So this is one formula in maths which you have to remember. Okay. Remember, this is applicable only for first derivative. Only when you differentiate a and b once, only then this. You cannot write it like, assume I differentiate a again. So d square a by dt square by d square b by dt square. You cannot write it as d square a by db square. This is wrong. You can't write it like this. But this is correct. Okay. Now, remember this result. Why have I told you this result? Now, in the third equation of motion, you don't have time. You want to get rid of time. Okay. All we have discussed is displacement time graph and velocity time graph. So, what I will do, dx by dt is what? Velocity. Final velocity. Remember, d. Yeah, tell me. dv by dt is acceleration. When I divide both, when I divide dv by dt upon dx by dt, you are going to get it as, what is this? dv by dt is what? Acceleration. dx by dt is velocity. Okay. Now, dv by dt by dx by dt, can write it as dv by dx. Remember, dA by dt, dB by dt, dA by dB. Correct? Is this clear? What I will do? What is so special? Acceleration is equal to vdv dx, and this is one of the very important result which you have to know. Okay, so this is a very important result which you have to know. Acceleration is nothing but v dv by dx. Remember this result, and this is going to help you a whole lot of times. Okay, so remember this result. Okay, so why did I tell you this result because we are going to be deriving the third equation of motion using that. What do we know? Acceleration is v vdv by dx. vdv is nothing but a dx. Okay. Now what I will do, I will integrate both sides. Now decide the limit now. Okay, we'll decide the limits. A car has traveled some path. At time t is equal to 0, car has some velocity u and displacement is 0. And at time t is equal to t, car has some final velocity v and displacement is s. Okay, so velocity limit is nothing but from u to v, u to v, and displacement is from 0 to s, 0 to s. That's all. Now just integrate both sides. Okay. Integral x power n dx is what? Tell me. X the power n plus 1 by n. Of course, integration constants is there. Okay. So integral x power n dx is x power n plus 1 by n plus 1. Now, so here n is nothing but what? N is equal to what? 1 u here. So we can write it as v square. Here n is nothing but what? 1. So here you can write it as v to the power 1 plus 1 by 1 plus 1. Okay. I will apply the limits now. Where is the limits from u to v? Here acceleration is constant. Okay, I have taken a outside. This is what? Integral dx. Okay, integral dx is nothing but x, where from 0 to s. Okay, so this is nothing but what? V square by 2 from u to v is equal to a x from 0 to s. Now just put the limits. What do you get after putting the limits? First you have put v square by minus upper limit minus lower limit. Then you have put u, so which is u square by 2, which is a into s minus. Take half common. V square minus u square equals a s. So there you go. V square minus u square cross multiply to a. So we have derived the third equation of motion using calculus method. So with this we have derived all the three equations of motion using graphical method as well as using calculus method. So I hope this is clear. So quick summary. Okay, so before going to exam, like you want all the three equations of motion, let us quickly revise. So quick summary. So what are the three equations of motion? What is the first equation of motion? V is equal to u plus at. Second equation of motion, s is equal to ut plus half at square. And third equation of motion, v square minus u square is 2as. What is the next topic which I am going to be discussing? The next topic which I am going to be discussing is questions on equations of motion. So I am going to be discussing questions on equations of motion. Okay, all the standard questions from board level till JE level. Okay, so all the types of questions or most important types of questions I am going to be discussing in next upcoming videos. So with this I end my video. If you have any doubts, let me know in the comments down below. Thank you. Bye bye.